A few years ago, the technology industry made a very confident announcement. Software engineers, one of the most in-demand, best-compensated professional groups in the modern economy, were going to be replaced by AI. Not gradually, not partially. Replaced. The tools were almost there. The cost savings would be enormous. The era of large engineering teams was coming to an end. Major technology companies began acting on this belief. Hiring freezes were put in place. Existing engineering teams were reduced. Thousands of developers who had spent years building careers at some of the most prestigious companies in the world found themselves out of work. The logic seemed airtight. AI could write code. Code was what software engineers did. Therefore, AI could do what software engineers did. The maths appeared simple. What the maths missed was everything that writing code is not. Because it turns out that writing code and building software are two entirely different things. And the gap between them, the gap that AI tools have consistently struggled to cross, is exactly where experienced software engineers live. This is the story of what happened when some of the largest technology companies in the world tested the proposition that AI could replace their engineers. What they found. And why, quietly and without much fanfare, a significant number of them are now reversing course. To understand why so many companies made this bet, it helps to understand what AI coding tools can actually do, because what they can do is genuinely impressive. Give a modern AI coding assistant a clear, specific instruction, and it will produce functional code in seconds. It can write in multiple programming languages. It can generate test cases, documentation, and boilerplate structures that previously consumed significant developer time. For straightforward, well-defined tasks, it is fast, accurate, and available around the clock without a salary, benefits, or the need to manage a career. For companies looking at their engineering payroll, one of their largest costs, the proposition was compelling. If AI could handle a meaningful portion of code generation, the number of humans required to produce software could be substantially reduced. Margins would improve. Productivity would increase. The competitive advantage would go to whoever moved fastest. This was not an irrational conclusion. It was a reasonable extrapolation from what the tools were demonstrably capable of. The problem was that it confused a part of the job with the whole of it. Writing code is one component of software engineering. It is, in many ways, the most visible component, the one that produces the tangible output you can point to and measure. But software engineering as a discipline is not primarily about writing code. It is about understanding problems, designing systems, making architectural decisions, anticipating failure modes, and building things that work not just in isolation, but within the complex, interconnected reality of a company's existing technical infrastructure. Those things require something that AI tools, in their current form, do not have. Not intelligence in the narrow sense. AI tools are clearly intelligent in narrow ways. But context, judgment, an understanding of why a system was built the way it was, what constraints shaped its design, and what the consequences of a change in one place might be somewhere else entirely. The problems that emerged when companies began relying heavily on AI-generated code fell into a few consistent categories, and understanding them reveals why the original calculation was incomplete. The first was volume without quality. AI tools generate code quickly. What companies discovered was that generating code and producing usable code are not the same thing. AI-generated code tends to work in isolation. It passes the tests it is asked to pass and produces the output it is asked to produce. What it struggles with is integration. Fitting new code into an existing system that has its own history, its own quirks, its own undocumented decisions made by engineers who have since left. This is where AI-generated code consistently fell short. The result was not less work for the remaining engineers. It was more work, reviewing and correcting outputs that looked right, but failed in practice. The second problem was the absence of business context. Software is not written in a vacuum. It is written to serve specific business objectives, within specific technical constraints. subject to specific strategic decisions that the company has made. An AI tool has no access to that context. It can write a function that performs correctly as a function. It cannot know that this function will be called by a system built on entirely different assumptions, or that the business rule it is implementing was changed 3 months ago and the documentation hasn't caught up. The third problem was self-correction, or the lack of it. When an experienced engineer makes a mistake, they typically catch it during review or testing. They understand the system well enough to recognize when something looks wrong even before it fails. AI tools do not have this capability in the same way. An error in AI-generated code is often subtle. The code runs, it does something, but not quite the right thing. Finding and fixing these errors requires exactly the kind of deep, contextual understanding that the AI lacked when it generated the code in the first place. The cumulative effect was that companies which had reduced their engineering teams found themselves with more code, more complexity, more errors, and fewer experienced people to deal with any of it. The response from companies has been quiet. There have been no major press releases announcing that the AI replacement strategy didn't work. No earnings calls where executives admitted the bet had not paid off. The reversal has been happening in job listings, in internal decisions, in the gradual rebuilding of engineering teams that were reduced not long ago. What companies are discovering is that the engineers they need now are not the same engineers they let go. Or rather, they are the same people, but the role has changed in a specific way. The junior developer role, entry level, handling straightforward tasks under supervision, has genuinely been affected by AI tools. Many of the tasks that would historically have been assigned to a junior engineer can now be handled adequately by AI. That part of the original prediction was not wrong. What was wrong was the assumption that removing junior engineers and replacing them with AI would allow companies to reduce their senior engineering headcount proportionally. What happened instead was the opposite. The more AI-generated code entered the system, the more experienced engineers were needed to supervise it, review it, catch its errors, and integrate it into systems it didn't fully understand. This has created a specific and somewhat ironic dynamic. Companies that reduced their engineering teams in anticipation of AI handling the work are now competing to hire experienced engineers. The same experienced engineers whose judgment was supposed to become unnecessary. The demand for senior engineering talent in many technology companies is, by multiple accounts, higher now than it was before the AI coding push began. There is also a phenomenon that has emerged specifically from the way these layoffs were conducted. Many of the engineers who were let go have been approached to return, sometimes by the same companies that dismissed them, sometimes by competitors who see the same shortage. The institutional knowledge they carry, the understanding of specific systems, specific code bases, specific architectural decisions, turns out to be difficult to replicate and impossible to generate with an AI tool. The software engineering story is instructive beyond the technology sector because it illustrates something important about where AI actually hits its limits, and why those limits are harder to see from the outside than they appear. The pattern that has emerged in software development, AI is highly capable at the narrow, well-defined task, but struggles with the contextual, systemic, judgment-heavy work that surrounds it, is likely to repeat in other professions as AI adoption deepens. In law, AI tools can conduct legal research and draft standard documents with impressive speed. What they cannot do is understand the specific context of a client relationship, the strategic objectives of a negotiation, or the unwritten norms of a particular jurisdiction that an experienced lawyer has absorbed over years of practice. In medicine, AI can analyze imaging data and flag patterns that a human radiologist might miss. What it cannot do is integrate that analysis with a patient's full history, their expressed concerns, the social context of their life, and the ethical complexity of treatment decisions. In finance, AI can process and analyze data at a scale no human team could match. What it cannot do is understand the specific dynamics of a client relationship, the political context of a boardroom decision, or the intuition that comes from having navigated multiple market cycles. In each of these cases, the pattern is similar to software engineering. AI performs well at the component level. It struggles at the systems level, at the work that requires understanding how components fit together within a complex, contextual, human reality. This does not mean AI will not continue to advance. It almost certainly will. But it does mean that the prediction of straightforward replacement, AI in, humans out, has consistently underestimated the complexity of what skilled professionals actually do. The software engineering experience is one of the earliest and clearest examples of that underestimation being tested against reality. So what does the software engineering story actually tell us? It tells us that the relationship between AI and skilled work is more complicated than either the most optimistic predictions or the most dismissive reactions have suggested. AI coding tools are not useless. They are genuinely useful for specific, well-defined tasks, for accelerating parts of the development process, for handling work that would previously have consumed significant junior developer time. The companies that are most effectively using these tools are not the ones that replace their engineers with them. They are the ones that gave their engineers access to them and watched what happened to productivity. What happened in many cases was that experienced engineers became significantly more capable. They could prototype faster, explore more options, handle more projects. The tool amplified their capability rather than replacing it, which is, as we have explored in previous videos on this channel, the pattern that tends to emerge when genuinely useful technology meets genuinely skilled people. The story of software engineering and AI is, in miniature, the story of technology and work more broadly. The prediction of replacement consistently oversimplifies. The reality is almost always more nuanced, a restructuring of what the work involves, who does which parts of it, and where human judgment remains indispensable even as machines handle more of the routine. The companies that made aggressive bets on AI replacing their engineering teams have, for the most part, learned this the hard way. The engineers who were let go in the confidence that they were no longer needed are, in many cases, being asked to come back. Not because AI failed entirely, it didn't, but because the gap between what AI can do and what building real software actually requires turned out to be wider than the original calculation assumed. That gap is where experienced engineers live. And for now, at least, it remains stubbornly human. At Macro Breakdown, we break down the economic forces shaping the world, clearly and without the noise. If this video gave you something to think about, subscribe, and we'll keep covering the stories that matter. Drop any questions in the comments below.